Mathematica Handbook is an ebook that helps you learn Mathematica and shows you how to use it to solve problems in science and engineering. It is an add-on to Mathematica, and Mathematica has to be installed on your computer to use it. It is available from MathematicaHandbook.com. Mathematica Handbook has three parts: a tutorial section, a section on mathematical methods in science and engineering, and a section on applications and case studies. The tutorial provides a crash course introduction to Mathematica syntax suitable for beginners. The notebook uses live code which has been tested on hundreds of students. Within an hour or two, you or your students will be able to use Mathematica to solve most math problems found in textbooks. Subsequent notebooks in the tutorial provide an introduction to more advanced topics, including symbolic computation, input and output of data files, and sophisticated graphics. The Mathematical Methods section has groups of notebooks which address standard topics in applied mathematics, including linear algebra, ordinary differential equations, vector analysis, and probability and statistics. The topics and level of presentation is similar to that in standard textbooks, such as those by Boas, Arfken, and Krasig. The emphasis in these notebooks is on mathematics, but they leverage the power of Mathematica commands, code, and high-quality static and animated graphics to present this material in a way that is clearer and more fun than conventional dead tree texts. The Case Studies section shows how to use Mathematica to solve more elaborate and challenging problems in science and engineering. Examples are taken from electromagnetism, quantum mechanics, fluid mechanics, and statistical mechanics. These problems make extensive use of numerical and symbolic calculations and sophisticated graphics. Next, I would like to show you how the Mathematica Handbook works within Mathematica and how it looks on your monitor. When you launch a standard Mathematica notebook, there are a number of tabs on the top toolbar. One of these is a palette menu. Palettes are free, small floating windows with buttons that typically are used to input special symbols or graphics. When you download and install the Mathematica Handbook, the installer automatically adds a new palette, which is the Mathematica Handbook Navigation palette. When you click on it, a new window opens that looks like this. It consists of a number of buttons and pull-down menus and provides a convenient way to navigate among the roughly 75 notebooks that make up the handbook. For example, if you click on the Tutorials button, you get a list of all the notebooks with a short description of the topics covered in each one. If we click, for example, on Intro to Mathematica Part 2, it opens a separate notebook that looks like this. This notebook has the structure of all the handbook notebooks. It has a short introductory section with hyperlinks to the various topics that are covered. We click, for example, on the Manipulate hyperlink. It takes us to that section automatically, which shows you how, step by step, to construct a short piece of code that will illustrate the convergence of the partial sums of a Fourier series. So by moving the slider, we can look at more and more partial sums and see how the series converges. As another example, let's open the Vectors and Integrals notebook in the tutorials, which looks like this. This notebook discusses some common pitfalls people encounter in technical calculations, as illustrated by a number of simple standard problems, such as calculating the magnetic field from a wire or the motion of a damp-driven harmonic oscillator. Let's click on the crystal geometry link, which takes us to a section that shows you how to construct a 3D graphic of the unit cell of an FCC crystal. And in Mathematica, these things are dynamic 3D drawings. Let's go back to the top of the notebook and pick another subject. Let's look at moments of inertia, which illustrates the problem of symbolic multiple integrals using the example of calculating the moment of inertia of a half disk and a cone. Let's take a quick look at some of the mathematical methods notebooks. I will click on the Ordinary Differential Equations button, which drops down a menu showing topics that range from analytic solutions through numerical methods and boundary value problems. Let's look at the Analytic Solutions notebook first. It looks like this. It starts off with a table of all the standard equations with closed form solutions. Let's click on the inhomogeneous second-order equations hyperlink to go to a detailed discussion. Mathematica has one-line commands which solve all of these equations, but it's important to understand the mathematics behind the solution algorithm, which in this case is based on variation of parameters or Green's functions. Both of these topics are discussed with the details presented in collapsed cells which can be opened up when you need them and then closed. By combining detailed derivations with examples using Mathematica syntax, the Mathematica Handbook provides a bridge between conventional texts and modern mathematical software. The general solution is illustrated with a few physical examples, including a mass on a spring subject to a driving force. A particularly interesting case is a sinusoidal force. The phenomena of beats and resonance are clearly illustrated using Mathematica graphics as we tune the frequency through the resonance. Finally, let's look at one of the notebooks in the application and case study section. They cover a wide range of topics. Let's pick the Schrödinger equation for the hydrogen atom, which is standard material in undergraduate chemistry and physics courses. The notebook looks like this. As usual, the problem statement and the central results and some useful definitions are given at the top of the notebook. These definitions and any of the code in any of the handbook notebooks can be copied and pasted into your own notebook and adapted to your particular application. Detailed solutions to the Schrödinger equation are accessed through hyperlinks. Mathematical issues which come up in these derivations, such as the form of the Laplacian and spherical coordinates, the solution of the radial differential equation, or the form and properties of the angular functions, all have hyperlinks which automatically open the various notebooks which cover these topics. We can look at some of the graphics generated by the solutions by clicking on this hyperlink, which show plots of the radial amplitudes and probabilities and contour plots of the electron density in various electron states. I hope this quick tour of the Mathematica Handbook has given you a feel for the type of contents and the way it works within Mathematica. I also hope it has convinced you that the handbook is a useful tool for learning the applications of Mathematica to science and engineering, either for self-study or in conjunction with the conventional class. The handbook has nearly 100 megabytes of notebooks and example data sets, and we've been able to show you only a tiny fraction of it. If you would like to learn more about the contents of the handbook, please visit the MathematicaHandbook.com website for a complete table of contents and an index of all the hyperlinks.